Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is going to be my third video on this sort of introduction to using the command line and getting really comfortable sort of with like terminal and using terminal. And then basically in this video I'm going to focus not necessarily on bash anymore. This video is going to be more on using Git, okay, and getting familiar with what Git does. Okay, and what Git is, all Git is a way of tracking the changes in your files. So what you do is you designate a folder. You say, hey, this folder and any files or folders in it are what's called a repository. Okay, it just means files that I want to track. And essentially what happens is that you get to track the change in the file. So the way it feels like you're making snapshots and copies of the files and saying, hey, I want to make a snapshot or a photograph of all my files as they are today. And these are referred to as commits. Okay, really what they are is they're saying, okay, from the last time you took a photograph, here's the things that have changed. So that way it doesn't have to like save all the information. But the idea is you create this, and let me see if I can find like a good chart of this. Actually, let me see here. I think I have a little chart here. Git draw. Was it the last? I think it might have been the last drawing I did. Yeah, here we go. So imagine that I say this particular folder that I'm working out of and all the files in it. So again, it's not just code. A lot of people think it's code. Git is just for tracking code. It could literally track any files. So like if you were an author and you were writing a book and you wanted to keep track of the versions of the book you're writing, you could use Git, and then you can go back to old versions of the book or create branches and whatnot. So but essentially what happens is that like every time I say, hey, Git, I want to create a commit, it's taking a snapshot of my files. Okay, the very first snapshot is pretty much the entirety of my files. Then the next snapshot is all the changes from the previous snapshot. So what you're doing is you're really tracking changes. And the beauty of this is that let's say I'm over here and you know what? I don't like the changes I've made. What I really want to do is go back to here and just start working from there going forward. I can actually go back in time and travel to a previous snapshot of my files. Okay, and yeah, a previous snapshot of my files. Cool. And the cool thing, another cool thing is that basically, let's say one day I want to write, like, let's say again, I'm using this to track writing a novel. So I've written chapter 5. I'm pretty happy with chapters 1 through 5. I have 2 ideas for a plot. So I have 2 ideas for chapter 6. But I can't really write them at the same time. What I could do is I could create 2 branches, which becomes like a different path of changes. So basically from this point going forward, so this is where I completed chapter 5. As I write chapter 6, I might have this version of chapter 6 and this version of chapter 6. And if later on I decide I really want this version of chapter 6, I can then merge those changes from that branch back into the main line. So what it does, it allows me to sort of like track the files, but it's not like I have a bunch of folders and copies of the files. There's only one file. But Git's tracking all these changes and all these pathways that I can then use. And this way, you know, when 2 people want to work on the same file, they are working on the same file without tripping over. Like that's where it's going to get used most for like code. So like if as a developer, like if I'm assigned to do something particular, what would happen without Git is if I change the file, but somebody else needs to work on the file, we're gonna end up keep changing each other's changes, and it's gonna become like a big mess. So what I can do is I can create my branch, make my changes. Who the other developer can make their own branch, make their changes, and then when we're done, we can merge all the changes together. And Git, for the most part, is pretty good at figuring out how to merge them together. Sometimes it doesn't, and you create what's called a merge conflict, but then you just go in there and you edit the text to make sure that the merge conflict is no longer there. So that's what Git is. It tracks versions of files, okay, by making these little snapshots of your files. Okay. So what I'm going to do here is in the bash practice folder that we made in the first 2 videos of this command line series, I'm going to create a new Git repository. So again, if you're on Mac or Linux, you should have Git out of the gate. If you listen to me for Windows and downloaded Git bash when we did the first video, you have Git through Git bash. And what you can do is you just type in like git init, and what that does, it creates a Git repository in whatever folder your terminal is currently in. Okay, so see there, I've created a Git repository. Now, how do you know that it exists? Well, what it does, it creates this folder here called .git. And again, any folder with a dot in front of it is hidden. So if I wanted to see that folder, I'd have to do like ls-la, And there it is. Okay, .git. So if you ever needed to like delete the repository, like you just need to get rid of it, you would just do rm, which stands for remove, -rf, and then .git in that folder. So be careful when you do that, because you want to accidentally delete. Never do like rm-rf tilde, because then you're going to erase your whole computer. Okay. You always want to name a specific folder you want to remove at the end of that command. Never like, and you always want to be like in the parent folder. So in this case, I'm in bash practice, which is the parent folder of the .git folder. So I'm saying, hey, from here, remove the .git folder, and that's here. Okay, because the rm command is the one command in bash that could do some damage, because again, you can accidentally erase your whole computer if you erase your home folder, or you erase the root folder, which is just slash. Okay, so technically, like slash here, that's the home folder. That's for Mac and Linux, it's the home folder. For like Windows, it would be like C. Okay, and then if you erase that, well, you erase the whole computer. Okay, but yes. So now I can do commands that you start with Git. So all the Git commands always start with Git. So if I want to see the status of my repository, I click Git status, and see it tells me that, hey, you have these files in here, and they haven't been tracked. Like you don't have them marked for tracking. So in that case, the next time I commit, those files won't be part of the snapshot. So I need to add them to what's called staging. Staging means these are the things I want to photograph. Okay? I could add them one by one, so I could be like git add letters.text. And see, now if I do git status, see, I see that letters is staged, so it's in green, meaning it will be snapshot on the next time I do a commit. So I will take a photograph of that file, while these two files will not be photographed, aka a commit. So if the shortcut is, if you want to add all of them, you have two choices. I could do git add -a, which adds all files, okay, regardless of where it is in your repository, or git add dot, which adds any files. Dot always represents the current folder, so it's anything in the current folder that I'm in and below. I usually do this because generally my terminal is going to be in the parent folder, like in the root folder. So in that case, I'm always going to capture everything that way. So I just do git add dot, and now if I do git status, it adds everything, because the dot means this folder, so it added everything that wasn't already added in this folder and below. Cool. So now if I want to create a commit, I just do git commit, the -m flag. This is really important, because if you don't put the -m flag, it wants you to write a message, like a little, like just a couple words about every, like for every commit. Okay. Now if I do the commit, if I do the -m, it lets me write the message right in the command. So I can just say, hey, here is my commit message. Okay. And see, I get this output, so I can see that, hey, like it committed it to what's called the main branch. Usually that's going to be called main or master, depending on how you installed your Git. Okay, but this just generally means like the default branch, like the main path of your code. Okay, and then there's the commit message. This is what's called the commit hash. So every commit gets a unique identifier, so that way you later on, if you want to, I could be like if I wanted to go back in time, I could be like Git Revert, Git Revert, what's the word I'm looking for? You would just type in the hash. So I would just copy this hash. So I'd be like BED 9E88, and that would change my code back, or at least would set where my repo is as far as what is committed back to that point in time. So I could go back and then erase all my changes that happened afterwards, and then commit going forward. So imagine, like, again, I'm going back to this image here. If I were to revert, it just says, okay, go back to over here. There's two ways to do this. Is revert, and I'm trying to remember what the other one is. Git Revert. Okay, it's Git Revert and Git. Well, if you just do Git Revert by with nothing afterwards, it'll just automatically revert the previous commit. But there's another one that's escaping me. Git Revert. Usually it'll, like, if you look at the documentation, it'll tell you like, yeah, there's this one and there's that one. Git Revert and Git. I know it starts with like the same letters. Reverse, replace, rebasing, not rebase. That's for like committing. Git Revert and Git Reset. Okay, so so I think resetting is what actually sets you back in time. So let me just double check that. So again, you can see like these images, like these are the commits. So again, and the head is always, the head is the version that you're looking at currently. So basically, whenever you see like this mention of like the head, let me see if I can find, like if I do git status, basically once you start having more commits, you start seeing like this mention of like the head. The head is a pointer that points to, this is what I want to see right now. So when I look through my computer, I want to see the files as of this commit. Okay, so usually the head is always at the very most recent commit, but you can actually move the head, and we'll talk about that in a moment. Okay, so you could see, so you see here, like I can move the head, meaning what I'm seeing, to a previous commit. Okay, so let's create another file just to kind of show you this at play. So if I do touch cheese.txt, okay, now if I do ls, I see cheese.txt with the other files. Okay, and then I do git status. See, it's untracked, so I'll do a git add dot git commit. Now here I'm going to commit without the -m flag, so you see what happens. So if I do a git commit without the flag, see, it takes me into an editor. On Linux, it takes me into Nano. On Mac, it's going to take you into Vim. So again, Vim, you have to use like the :WQ to quit. Here on Linux, I would just put it like type a message saying, hey, this is my commit, right there at the top. And then I would do Control-X to exit Nano, hit yes, enter, and see like I did my commit. It's easier to avoid all that by using the -m flag. So you can just type your message when you do the commit. But see, now I have another commit. So if I were to do git log, see, I can see all my previous commits and I can see their hashes. So if I were to do git revert, it would go backwards and get rid of this commit. So like if I do git revert, actually, well, let's see here, let's just see here, git revert. Okay, nope, didn't like that, so I think git reset. Yep, and now if I do log, git log, oh, well, I didn't really do anything. Okay, so if I want to go back, well, first let's just establish something. Okay, git reset, git log, so we see my two commits, and again we see their hashes. So again, git log will always show us our previous history. But what I want to do is like go back. I want to go back in time. So again, right now I see all my files, cheese.txt, letters.txt, script.1. If I do git reset, I'm pretty sure git reset will take me back. Git revert, what it does, it creates a new commit that changes all my files back to the other one, but let's just test that out. Git reset, and then what I would do is put the commit hash that I want to go back to. Okay, so this is the older one. So I'm going to say, hey, I want to go back to that. Okay, now if I do git log, let's see what happens. And see, like now the previous commit is gone. Because what I said is, like I said, reset my repo back to that. And if I do git status, cheese.txt is still there because it doesn't delete all your changes. When you say git reset, by default, you could make it changes. There's like some flags you can pass. But what it does, it just says, okay, the only code that is committed, or the only stuff that's committed, is anything as of this point. So git reset just takes me back to that point, and then I can go back and then change things and then commit going forward. Okay, but let me just do that commit again. So let's say git add dot git commit -m. I commit it again. And then if I do a git log, see, I commit it again, and then my first commit, but that other commit I had made a second ago is gone because I had reset backwards and then recommitted. Okay, so I can go back and forwards in time. That's the benefit of Git. I can, not only can I change versions, like let's say I just wanted to look at the previous commit. I didn't want to like erase the current commit. I just want to go back in time for a second. I can do like git checkout, and git checkout will let me change where my head is pointing. So I'm going to say, hey, you know, right now I want to point the head, because see, right now the head is pointing at the newest commit, so you can see that there. I want to say, hey, I want to look at my files as of this commit. So I put that there. Okay, and it says I'm in detached head state, meaning like, hey, I can't really edit files here because I already have commits after this commit, but I can look at my files. Okay, and if I do ls, see, cheese is not there because it's just showing me my files as of that commit. Okay, but then if I go back, if I say like git checkout, I'm pretty sure I can just type in head, or actually, not git checkout head, I want to do git checkout main. That's the name of the branch. It'll take me back to the tip of the branch. Okay. So now if I do ls, see cheese is back. Okay, so cheese is back because now basically what happened is that I was here. I used the git checkout to move to this commit, so I only saw the files that existed at that commit. Then I did git checkout main, so it took me back to the last commit in that particular branch. Okay, so I can move back and forth to take a look at my files. If I just want to see, hey, how did things look back a few commits ago? Then now let's see what happens if I do like a git revert. Git revert, and let's take this scope. So instead of wanting to reset back to that commit, I'm going to do a git revert. Okay, and you see here's the revert. Here's my commit message, and see it says changes to be committed. And it's going to delete these files. Interesting. Okay, but I hit Control X to save those changes, and I hit ls, and it deleted those other files. Because what I did is I said I want to undo that commit. So that commit added these files. So what it is, it made a new commit that undoes the changes in that particular commit. So now I just have cheese.txt, but the previous commits are still there. So if I do a git log, see, notice I didn't erase the previous commits. I did not erase them. All I did is I created a new commit that went back and deleted the things I added in the past. So that's the difference between reset and revert. Reset is going to take you back in time and erase the history. So that history is gone. So those commits don't exist anymore. Revert undoes the changes to the files in a new commit, so the previous commits still exist in your history, in case you still want them. So it just depends, like, do you want those previous versions to still exist? Okay, because sometimes maybe the reason you want to reset is because there's sensitive information you accidentally committed and you want to uncommit it. So that way you can not have sensitive information in your Git. But other times you do want to keep those changes for like reference, but you still want to undo them, and then that's when you would use revert. Okay, so hopefully that clarifies a little bit better like what Git Revert and Git Reset do. Okay, I can create more branches. Okay, so again, if I want to create a branch, let's show you an example of that. So here's like a branch. So you see, like, here's a commit, and now I have two paths. Okay, so here's like one branch, and here's the main branch. And I can do commits that go along this branch and commits that go along this branch. To do that, you just do git checkout -b, meaning you want to create a new branch, and you say, hey, this is my other, and you give the branch a name, other branch. So notice my prompt change. I'm no longer on the main branch, I'm on the other branch. So now any commits I make going forward, so let's make another file. So let's say touchbread.txt. Okay. Cool. Touchbread.txt. And I want to make another commit. So git add dot git commit -m hello from other branch. Now look, this commit isn't on the main branch, it's on other branch. But now when I do a git log from here, I see that the most recent commit based on the branch that I'm currently on is these, but the previous commits were made from the main branch. So because it branched off. But I can switch back to the main branch by doing git checkout main. And then if I do a git log, okay, see, now I only see the branches, the commits that are on main. Okay. So that's pretty cool. Now if I want to know what branches I had, I can just do git branch. And this would show me what branches exist. Okay. Now if I wanted to take the code that I have in that other branch and move it into this branch, what I could do is I could do a git merge and then put the name of the other branch. So I just say git merge other branch, and that's going to merge in the code. So what it does, see, it took the code from the other file and see it added bread.txt. It says so right there. It's like, okay, we added bread.txt because that's what was in that commit on the other branch. Okay, so going back to that drawing, see, we took the commit that I had on the other branch and just merged it in. So those changes are now also included here. Okay, so that's pretty cool. So that's pretty much like what Git does. Git can do a lot more, but that's already kind of a bit like, main thing is just being able to make those commits and track your files. But the real benefit of this is working with other developers. So that way every developer, so again, I would be making branches when I work on something, then merging it in when I'm done. But usually the way we do this is we want to interact somewhere online so where we can share the code. So we use what's called a remote repository. This could be like GitHub. So the main websites for this are going to be like github.com, Bitbucket, and gitlab.com. And basically, all these sites are free. Recommend having an account on all three. It's always good to have all three. So let me just log into these things. Nope, that's not how I want to log in. I think I have an account under my Google account. Oh, I guess I'll figure that out later. Alex Merced FNM. Oh, this must be a new one. I have to figure out which account that the previous one was at, but we'll just do that. Username, we'll just say Alex Merced Coder. Okay, skip this. Okay, so I have a new Bitbucket account. Fine. Cool. Although that means I'm not going to have my SSH key here. Oh well, we'll figure that out in a second. Okay. And you can log in here. I'll just show you from GitHub just to kind of get straight to the point. But on any of these tools, okay, they all do the same thing. They have different features that you can take advantage of. Is what you do is you create a new remote repository, which means a repository on another computer. Okay, it doesn't have to be one of these three services. Someone could have their own Git server, and you can host remotes on that remote Git server. Amazon has their own like remote hosting service. But the idea is that these are like, this is a separate repo. It's not the same thing as the repo on your computer. There's your local repo, and this is going to be another repo that we're going to share code with, or share commits with. So what's going to happen is I'm going to create this repo on GitHub, and then I'm going to be able to connect that repo to the repo I have on my computer, and every once in a while I'm going to want to push commits to it and say, hey, I want to share you my new commits, so that way I have a copy of all these commits online. So that way other people who want to work with me can see my new code changes, I can see their code changes, because we're all sharing those commits through a remote repository like GitHub. So, I would do this, and I would say like, we'll call this like bash practice video. Okay, I'll make it public. I'm not going to check off any of these other things. And what's going to happen is that to add this remote, what I'm going to want to do is copy this URL. That's really what matters. Now notice that there's two buttons here, HTTPS and SSH. If you don't have SSH set up, if you don't know whether you do, then you don't have it set up. Okay, I do recommend setting up SSH. I think it makes life easier. There is a video on that. Just look up Alex Merced setting up SSH keys, and you can set up SSH for your GitHub account. HTTPS would just be normal. You don't necessarily have to set up an SSH key and do all that. It's pretty, again, setting up an SSH key is pretty easy. Yeah, so basically what I'm going to do is I'm going to copy this URL, copy it. So again, make sure you're copying the right one. SSH, if you have SSH set up, all other situations use HTTPS instead. Okay, and then what I'm going to do is I'm going to say, hey, you know what? This Git Remote is a bunch of commands for me to control, like how many remotes what other remote repos am I sharing code with. So I can say Git Remote, and I want to add a remote. Okay, so I'm adding a new remote. I have to give it a name. Usually the first remote you add is called origin, but it doesn't have to be. It could be called whatever you want. Okay, so git remote add origin, and then you paste the URL. So anytime I refer to origin, I'm referring to this particular URL as far as where that repository is located. Okay, git remote add origin, get a GitHub. And now if I do git remote -v, it's going to list all my remotes. Okay, so I can see I have currently, and it always adds 2 for each remote, because there's one for like, because you can get code from the remote. Like I can actually do a pull, where what it does, it checks the remote to see if there's any new commits I don't have, and then pulls down those commits. And then there's push, where it says, hey, do I have any new commits that I don't have online? And then it'll push up those commits. That's essentially how this works. And again, you can have multiple of these remotes. So I could connect, like sometimes I'll have one on GitHub, Bitbucket, and GitLab on all 3 of them, and I'll just push to all 3 of them, so that way I have 3 copies. Because you never know when one site's going to be down or something. Okay, so and you can have multiple origins at the same place. There's all sorts of cool things you can do with this. But now, if I wanted to push up my commits, I would just do git push origin, and I say which branch I want to push. So I say git push origin main, and now what it does, it pushes any commits that are on the main branch that the remote doesn't have up to the remote. Okay, and then that does that. So now, if I go over here and I refresh the page, now my code is online. Okay, and now I can have this code. Other people can take a look at my code, or again, it doesn't have to be code. It could be a book. You could be just a text. It could be like a Word file where you're writing a book. Again, Git just tracks versions of files. It's mostly used for code, but it doesn't have to be used for code. And if you notice, like a lot of these, like now, like online, like if you use like Google Docs and whatnot, you notice you can like roll back versions of files. That's because under the hood they're using Git, and they're giving you a graphical interface over using Git over those files. So technically, you're using this anytime you work on any kind of online document, and you're able to kind of roll back versions and see previous changes and stuff like that. But yeah, so that's like the basics of Git and GitHub. There's so much more. I do have other videos on GitHub and Git, so that way you can learn even more. But essentially, that's what Git does. This is a really major piece, again, especially if you're working as a developer, in tracking your files. This is how we share. This is how we, keep track of the versions of our code, so that way we're not having to that way if we make too big of a mistake, we're not stuck having to redo the whole thing. You generally want to commit often, okay? The way you want to think about it is that every small identifiable bit of a code, you want to do a commit. And committing, at the end of the day, you're committing the same changes. So if I commit the same changes to my files over 10 commits versus 1 commit, there isn't like a huge file size difference. Again, there might be a little bit more text in the list of commits, but you're tracking the same changes to your file. So you're not, like, don't think you're making a copy of your files every time you commit, because that's why some people, like, what they do is they commit like once a day or once a week, but you really want to be committing like every hour. But really, it's like after every sort of like, hey, I completed this functional piece, let me commit it, saying, hey, I have this piece and it's working now. Okay, let me work on the next piece, commit it, then work on the next piece, then commit it. So that way, again, anything breaks, you can go back to a reasonable, you don't lose too much when you go back. But my name is Alex Merced from alexmercedcore.com. Hopefully you guys enjoyed this. I'll see you all later. Have a great day and enjoy.